friends, today we're going to talk about graphing horizontal and vertical lines. These look a little different than the lines that look like a y equals mx plus b form because they only involve one of our variables of x or y. So they can be challenging, but the truth is they're some of our easiest lines to graph once you know what you're looking for. All right, a horizontal line, we talked earlier about the fact that a horizontal line has a slope of 0. All right, so if we have a y equals mx plus b form, a horizontal line would say y equals 0x plus b, which really means we've got y equals this y-intercept, which makes sense. We have a horizontal line and it's all defined by where it touches the y-axis. So a horizontal line is going to look like y equals some number b, and that's going to be our horizontal line. Now, let me go ahead and circle it so we don't lose that. Also, did you know it's hard to spell horizontal while you're talking? All right, vertical lines. Now, vertical lines are a little bit different. If we think about a vertical line, it doesn't have a slope to it. We say the slope is undefined. Okay. Now, in another video, I talked about a zero slope means that if I set a ball on this horizontal line, it would move 0. It's just going to sit there. I like to think of undefined in the same way. If I had a vertical line, I cannot set a ball on it, right? There's no setting anything on a vertical line. So the ability to set something on it, that's undefined. That helps me remember that the vertical lines have an undefined slope. Vertical lines are x equals something, some number a, and a is where it's going to touch the x-axis. This is our vertical line. All right, so if we're given an equation, we want to figure out, are we being given a vertical line or a horizontal line? And then we can graph it. Let's look at a couple of examples. All right, first we want to look at the line y equals 1. Now, I could think of this as y equals 0 times x plus 1. Knowing that I have a slope of 0, that's one way to think of it, or I could just remember that y equals defines a horizontal line. So let's draw our axes. So I have a horizontal line that I'll label x and a vertical line that I'll label y, and they intersect at right angles. And I'm going to mark off a few units from the origin along each axis, creating my own little graph paper here on the screen. All right, so the line y equals 1, we could think of this as having a y-intercept of 1, which I would place on the graph at the point 0, 1. And then we also know that for any other value of x, the y value is going to be 1. It's going to be 1 for every x value. So this would be a horizontal line at y equal 1, so it would extend to the right and to the left infinitely from this point 0, 1. And I could label it as y equal 1. We do want to have arrows on the end to show that it goes on forever in both directions. All right, next let's look at the line x equals -2. Well, let's draw our axes. So the x-axis will be my horizontal line, and the y-axis is my vertical line. And I'm going to mark off a few units in each direction from the origin on my graph. All right, we want the line x equals -2. We know this is a vertical line because it's x equals. So we want to start at the point where it's going to intersect the x-axis at -2. So that would be the point -2, 0. And then I can draw a vertical line through that point. We're going to pretend that's a straight line. And so along that line, all of the x values will be -2. The y value will change, but the x value will be -2 along the entire line. So that is the line x equals -2. All right? Now, there's one other type of problem I want to run through, and it looks a little more complicated, but when you understand what it's asking, it's not too bad. So this would be the type of problem that says, graph the horizontal and vertical lines through the point (3, -2). Okay. First, I'm going to just graph this point on a coordinate system so that we can look at what's happening here. So I will start with my x-axis, that horizontal line labeled x. Y-axis is my vertical line through the middle of it, labeled y. I'm going to mark off a few units in each direction. And then I'm going to plot the point 3, -2. So I'll start at the origin and I'll move 1, 2, 3 to the right and 2 units down and put that point there. All right, so we're being asked for 2 separate things. The horizontal line through that point and the vertical line through that point. So let's take them separately. So the horizontal, well, if I were to graph that line, I would just extend from that point directly left and directly right. And I'd be able to tell that this is going to touch the y-axis at -2. Notice that my y-coordinate of the point is -2, and those connect on purpose. The horizontal line through that point is y equals -2. We know it's y equals because it's a horizontal line, and it's going to refer back to the y part of that point. So that line would just be y equals -2. All right, and then for the vertical line, let's go back to my point 3, 2. I'm going to extend vertically from that point in both up and down. So we've got a visual on that. It's a vertical line. And you'll notice it touches the x-axis at x equals 3. That's on purpose. If you notice in our point, 3 is the x-coordinate. So the vertical line, its x equals, because it is a vertical line, and we know vertical is always defined by x, and its x equals 3, the x-coordinate of the point gives us the vertical line through that point. All right, so the point 3, 2, the horizontal line going through it is the line y equals, 3, -2. The horizontal line is the line y equals -2. And the vertical line is the line x equals 3. And we could have read that off of the point now that we understand how it all works together. All right, hopefully this gives you a good start on being able to graph lines, including the horizontal and the vertical lines.